Welcome back to this AI tutorial. So this is part 3 where we're going to work on senses. So let's just recap quickly what we had going before. So we've got this behavior tree with an idle handler. We've got something that handles going to the guard target, which is an object that we've set in the blackboard. If we're essentially slightly higher priority than idle, then we're going to start adding something for if we hear a sound, and eventually we'll add another subtree down here, which when we see an enemy or see something happen. And then finally the sort of highest priority is if we get outside of a specific range, and this is set to 1,000 now, but it probably should be something bigger than that. So essentially we've got to start fleshing out this tree. Now just before we start, remember that last time we just added a pawn sensing component, in the components section, a pawn sensing component to our controller, and we've added these two events. And what I've done is I've just added a print string for each one of them so that we can see whether that's actually happening. So if I go and run our scene right now, you can see that the C's pawn print string is working. I'll go and make a noise. So our AI's definitely heard a noise. So just a quick word on that. The noise itself is coming from, where are we in the blueprints? In my character blueprint, there's an interesting thing here in that the character blueprint has to have a player pawn noise emitter on it for it to be able to emit a noise that the AI can understand. So if you're wanting to do this kind of thing where you're creating noises, the pawns that are creating the noises have to have one of these noise emitters. I'm not entirely sure why that is, but that's just something it says in the documentation. So in this case I have, if I press the F key, I call the make noise. I use myself, the pawn, as the noise instigator, and it sets the location for a sound and plays out that sound at that location. Now obviously anything can make the noises here, it's just a matter of I wanted to be able to test something by pressing a key, and the player seemed like the good place to do it. So what we're going to do really is we're going to concentrate on fleshing out some of this information. We're going to start with the hearing one, not because it's easy particularly, but just because we might as well start, if we look at the priority, we might as well start at the lowest priority one first. So what we've got to do is we've got to add something in this hearing noise system that fills in some information. So let's go back to our behavior tree. Oh, there's something else that we should probably fix here, right? So I think last time we had a few variables, and for some reason I seem to have picked up a couple more. So let's go to the blackboard and just fix that for now. Self actor, we can delete that. Object key, we can delete that one. I don't think we're using it. So we should have a guard target, which is our target location that we're going to be a guard for. Our distance to guard target, which is calculated, if you remember, in the service that we're running here. And I added an investigate position last time. Now one of the problems with that is that a vector 3 is essentially, when the blackboard runs, the vector 3, we don't necessarily know what value it's going to be initialized to. And actually there's no real way to know whether a vector 3 is a sort of valid value or whether it's a value that we should be interested in. So I think that what we should do is when we're looking at hearing and noise, especially for the behavior tree, we want to know whether we've actually heard something. So the question is, do we do some kind of test on this key? That should eventually update itself, and we should have only three variables in there. We'll wait and see if it refreshes. So the question is, should we have something that says yes, we've heard a sound? And I'm thinking that's probably the best way to do it. So let's go and add in a new key here, which is a bool that has let's call it has heard noise. So what we're saying is, if this has heard noise thing is set, then we're going to use the investigate position. So somehow we'll have to set that value. And what we can do is, if we go back to our behavior tree, we can say, okay, so we can add a blackboard decorator to say if has heard noise is set. I see that just updated there. Seems like using one of these is saying whatever. So let's just give it a description. So if has heard noise is set, then we're going to run some kind of behavior. So so we know that we're going to get that noise event in our controller. The question is, what do we want to fill in when we get the noise event? So let's just save that behavior tree for now. Well, actually, no, let's fill in the actual behavior itself. So we know we need to move to, if I could spell it, move to, and in this case we're going to move to the investigate position. We're not moving to an object, we're moving to a point in space, or near enough a point in space. And let's give that a value of, say, 60 to sort of give it approximation. And then let's just set up a wait for now. Now there's something else we probably want to do, but I'm setting up a wait so that we know. Let's give it a sort of 3-second wait rather than a 5-second. That's a bit long. So I'm setting up that wait because essentially what would happen is, if we were running this part of the tree, you would move to the position and then immediately this part fail out of this tree, because it would essentially get to where it was going, and then this tree would kick back in and it would run back to its starting point. So it's kind of, it would just ping pong between the two generally. Oh, nice cup of tea. So anyway, one thing we need to think about is this problem of, okay, so we've moved to our position where we heard the noise. We should probably do something more interesting there eventually. But one thing we've got to think about is, okay, so we've got a bool that says if we've heard a noise, and somewhere we're going to set that. But how does it get reset? Because essentially, if it doesn't get reset, it will just constantly run this set of nodes. So maybe we need to think about having some kind of task that resets the boolean in the blackboard essentially to false when we've completed this sequence, because this is obviously a sequence when we hear something. So let's do that now. Let's start with a new task, blueprint base. Now, usually I like to rename the task before I edit it. You don't necessarily have to. And what we're saying is, if we get the well, actually we could just say when we receive an execute, we can set the blackboard as bool. Now we need a key name, so let's just add a let's just set this as a blackboard key selector, and we need an actual bool to say it to, so let's go bool and call that bool value. Remember to set them both to public so that we can actually see them. Don't worry about this error for now. So we can drag that key to set, and we can drag the bool value. So what's essentially happening here is when we receive an execute, we'll set the blackboard value to whatever's in this bool value, which is a sort of public variable that we can set on the actual task. The next thing we need to do is we need to finish the execute. And let's say yes, it's true. So essentially, whenever this node executes, it sets the blackboard value to whatever's in that variable and then finishes. Really simple task. Now, one thing we might want to think about is what happens if I go back to the behavior tree and show you that. Actually, let's just save that and compile it, and then let's go and rename that, because I don't like having tasks named like that. So let's call it btt underscore set bb bool. Bool. Yes. Yeah, let's just say yes to that because it's just only one reference in memory. So basically we've got a task now that we can create that sets the blackboard value as a bool. And if we go back to here, we can use that set bb bool. And again, we can say, okay, so has heard noise should be false. We set hurdle. Nope, heard. And we don't want to show property details, so take that off. So one thing that will happen is that if this tree runs, it'll move to the position where it heard something, it'll wait for 3 seconds, and then it will reset whether it's heard something, and that will become false, which means this tree will execute, or that tree will execute. So one thing we want to do is we want to change the observer aborts to lower priority. And once you see, when you change that, what's that saying is, if this condition is true, then anything that's running in this area, anything of these two trees, aborts, and this one runs as priority. So essentially, when you look at it, we're looking at priority in left to right order. So this is the lowest priority, this is the second lowest, this is the third lowest, and we'll obviously flesh out this one as well. So let's just save that. So what we need to do now is we've got our investigate position, we've got a boolean that we need to set to say yes, we should probably go there, and we've got an event that's happening when we should actually go there itself. So easiest thing to do is to okay, let's get the blackboard for a start. And it takes a reference to self. So we'll do this quite a lot. set black, if I could spell, wouldn't it? Set value as, well, let's set the vector first. Set value as vector. And then let's just shove this up here. And we have a set value as bool. So remember, we've got a vector that's the position, and we've got a bool that's the a vector that's position, and a bool that tells it basically it's heard something. So what else do we need? We need to hook up the location of where that noise was generated to, because this is one thing that you get passed from the sensing component. And we need to come up with a key name. So let's add a few variables here. We need a key name. And let's call that investigate position key name. And make that public and drag it out to there. And we need another one. Noise bool key name. You could call these things anything, by the way. It's the actual value of them that makes the difference. So let's just save and compile that. Once you compile it, you can actually give it a default value. So the actual value that we want to give these keys is the name of the blackboard variables that we're going to fill in. So investigate position for the vector one, and has heard noise for the other one. So let's go to investigate position key name. It's called investigate position, and in case of this one, let's just select that one, has heard noise. So basically these are literal strings essentially that are getting passed to the blackboard to tell it which values to use. And that should say, okay, so when we hear a sound, we're going to go and when we hear a sound, we're going to set the position of that sound in this blackboard, and we're going to set the bool to say we've heard a sound to true, which means that our behavior tree, this conditional will become true, which means that it should run this set of nodes, unless this one's already running, in which case this one gets priority. So there's there are a couple of things that we probably should fix first. One of them is, if you think about it, this is going to get run whenever it hears a sound, but there's no check on whether that sound is actually within a specified distance. I mean, obviously the pawn sensing component, the sort of hearing thing, has a distance value set on it, but that doesn't mean to say that it's valid for our particular behavior tree setup. Remember that the behavior tree, if it gets beyond a certain distance, the character will just go back to its starting point, its guard location. So there might be some problem when we run it because of this. So let's just give it a quick run and see what it says. I'll just have a quick play And you should notice something when we're doing this. So if I'm within a reasonable distance and I press my F key to make a sound, the guy will come along, wait 3 seconds and then go back, which is what I expect. So let's make sure it just works, because it can go any direction. Yep. Okay, wait 3 seconds and go back, which is good. Now then, there's a problem in that if I move further away beyond the 1000 distance for moving to guard target, it doesn't actually hear the sound outside of that location anyway. Ooh. Oops. So I've heard a sound, and that's the problem, right? He basically gets into a loop. And when you think about it, that makes perfect sense, because what's actually happening is it's moving towards the sound, but then this tree is taking over. It's saying, you know, my guard target is set and I'm greater than a specific distance. And what you're actually getting is this sort of ping-ponging behavior, which is definitely not what you want. So one thing we probably want to do is we want to have some kind of filtering on. Let's just stop there. We want to have some kind of filtering on when that particular function is run, right? So one thing we could do is we could maybe think of getting hold of this location and comparing it to our current location and saying if it's within a certain distance, then we've heard something. So essentially we're adding a filter into this to say if we're within, I mean, it depends on what value we want to use, but if we're within a certain range, we should only do the logic based on that. So let's just drag the print string. So let's do an if statement here. I'll get the range first. So we can get the controlled pawn. And we can get nav. So you can get the navigation agent location, which is basically the position of the sort of navigation guy, which is what we're using to actually move the thing around. And we can take the current location and subtract. So just press the minus key. We can subtract this vector from it. And we can get the length of that, so vector length. And we can say if, so as a branch, let's just hook that up. Is less than didn't quite hit that. There you go. So in here, let's put something like 900. Remember our sort of maximum value for moving to the target point was 1000. So what we're saying is we'll only go and investigate a sound if it's within 900. Now ideally we would probably want to make this come from the blackboard itself actually. Maybe that's some value that we should expose to there, but for now let's just use that as a control. So that just means that when it investigates a sound, it only investigates a sound within a certain radius. So that's the hearing part of the behavior tree sorted out. what we should be able to do, let's just run it again. So he's running the main tree to go back to his start point. Create a noise, he'll come and see us. Then he'll go back. He heard that sound, but because we were too far away and he couldn't actually get to us, he's just ignored it. So that seems to be working. And at some point we'll get to a threshold where he can actually come and get to us and then go back. So that looks like that's working okay. And we're resetting, it seems alright. Let's just run that. It's kind of hard to show you it, but let's see if I can. So let's play that. Can I? Yeah. Not the best way of showing it, but whatever. So it's idling. We come over here. We make a sound. It goes into the sound tree, which is alright. We've heard something. Goes back. So you notice that the second go back to guard target location thing was set. If we play a sound outside of our radius, it doesn't even activate that tree. So that's good. It's useful to have a dual monitor if you're going to debug these things, because you want to see where your behavior tree is actually activating or not. Just as a sort of useful way of doing things. So make sure if you can that you're using a dual monitor setup. So the next part is that we need to do essentially the same kind of thing, but for the other sense, which is the seeing pawn sense. Now, if you notice in the demos, we're actually starting off seeing the seeing thing. The seeing component of that pawn sensing component says that it only sees things that are essentially directly in front of it. So it can actually kind of be directly behind and not be sensed. So that's something to bear in mind if you want other kinds of behavior. Maybe you want something where it's actually checking a distance and not just whether it's in front or not. So I'll have a quick break to select my tea down, and then we'll fix that next section up. Okay, so what we're working on next is we're going to have our behavior tree respond to seeing something. So let's just move these nodes around a bit. Give ourselves a bit of space to play with. Just gets a little bit harder to see what's going on in a particular part of the tree. So we've got a guard target. We've got the distance we are from that guard target, updating that service. We've got an investigate position and whether we've heard a noise or not, and whether we should go and investigate it. So the next part is that we need to respond to seeing an enemy. Now, if we think about it, all we're saying is if there is an enemy object set in our blackboard, then we should do some kind of behavior. So let's go and add our blackboard a new key of type object, enemy object. Now let's call it enemy X. I don't like the name there. And don't forget, we need to set our base class to actor. So we can use our blackboard again to say one thing we want to do is we want to make sure that we only run this node if our enemy actor is set. So what else might we want to use conditionally? Now we might want to do something on here that we haven't got available, and that is we might want to check our line of sight to the enemy. So it's not just that we sort of see something, it's that maybe we want to continuously check a line of sight. As it is, our sensing component probably already does that for us, so we maybe don't need to have that. So let's just check that for now. So one thing we need to do is we need to get our pawn sensing component again to store the pawn. In our blackboard again, right? So basically we're doing the same as we did here, but for the seeing senses. So we need a new variable of type name. Let's call this enemy actor key name and make it public again. So we need to, well, we can copy these nodes. We need to get the blackboard and set, I think there's a set value as actor. There was a set value as actor somewhere. Obviously it's not in this scope, but whatever. And then we just need our enemy actor key name dragged in there. And finally, we can drag our pawn into there. So let's just move that a little bit. Trouble with visual programming systems is they are all over the place. So simple, essentially when it sees something, that thing gets stored in the blackboard under this key name. So we need to set the key name. We need to save and compile it first before it gives us the default field to fill in, and let's call that enemy actor. Now those who are switched on view might have noticed that we haven't necessarily, like pawn isn't necessarily an actor. I suppose it is an actor in its base class, so that should be alright, but you can only sense pawns, which might or might not be useful for you. And the other thing is that we've no way of saying whether it's an enemy or a friendly. So we might want to extend this functionality later on to do some checks on something. Now we might use the tagging system to add like faction tags and those kind of things, but for now let's just save and compile that and see if that works. So what we're saying is if this value is set, then we're going to move to and this time we're going to move to enemy actor, Do we need a way? No, probably don't. Let's just see how that works out for now. So what we've done is we've added the enemy actor object. We've set it in the guard controller when we sense the pawn. The one thing to notice actually is that, and I didn't realise this before but I was speaking to Mika, sometimes the blackboard values aren't initialised. So watch out for that. I've actually asked him to add an event for like essentially an initialization event on the blackboard before it gets used by the behavior tree, just so things like vector positions can be set to 0 and actor objects can be set to null, etc. So let's see what we get when we play it. What we should get is that if the guy gets to, oh look, yeah, okay, so he's already seen me before, he will actually go back to where he started and he'll come after me. And then he gets to a certain distance away, now one thing that's not happening here is that he's not actually forgetting me. If we look at the behavior tree as it's running, let's just grab that. It's ping-ponging again between, because he's got our enemy actor set, and then he's moving to it. Also notice this, right? So basically when we've run this particular thing, because we've never set this up, we've actually got an invalid value in that position vector. You know, I was mentioning about things not being initialized. Well, blackboard values, yeah. Just be careful when you're using blackboards that you have some way of either initializing them. There isn't really a good way right now. Actors apparently are set to null or invalid when they start, but some things aren't. Some things aren't initialized properly. It's kind of, yeah, I think that needs to change. So anyway, we need to have something that says, okay, so once we've reached, we should really basically forget that we've seen the actor at that point. So like when the move completes, we should have something that allows us to reset the enemy actor. So let's do that now. So what we need is we need a new task. Now I might have already created that task now. Did I already create that task? I'll just check it 1 second. I should probably not have. May have. Nope. Okay, reset target. Well, in this case, let's just create a new task. So, go to our behavior tree, new task, blueprint base again. I dislike the fact that it just calls it blueprint base. Yeah, don't. It's. So, again, BT task. I think that. BB, oops, no, let's call it set BB actor. I'm trying to make these things kind of generic, because they should basically work on a generic blackboard. The idea being that if you've got an object set in a blackboard and you want to reset it, then it should be able to set any basically any actor. So again, we add an event, So we get the receive event execute, and we set blackboard value as object. So we need a key. Again, it's a blackboard key selector for the name of the object that we're going to. So we need another variable which is of type object. Let's call it an actor. So that's the key. That's the actor to set. And then finish. Can't spell finish. So essentially what we're saying here is when we execute this task node, set the blackboard value of this key name, and that will be filled in when we're actually editing the behavior tree with this actor value. And again, the actor value will be filled in when we edit in the behavior tree. So I'm hoping that this value will default to null, which means that we can then reset an actor to nothing. So that should, I've got in the habit of sort of saving and compiling in when I don't need to. So that should give us the ability to set BB actor. Take that off, and we can do enemy actor to none. So essentially, when we've moved to the enemy, forget him, which means that this will bail out. We should probably do this reset at the end of a sequence, a sequence of operations, so maybe move to and then hit, and then if he dies, we'll do that. One thing to notice about tasks is that if a tree takes control of priority, so basically if one of the sort of values changes in the behavior tree which causes the priority to shift, which means that some of these values increase, and essentially flow control goes down a different tree, it isn't always correct that your nodes are run. And by that I mean that it might be that this reset is never called if we're in this tree and we're moving to somewhere and this value kicks in and says, okay, we're too far away from our guard target. This tree runs, this one stops executing wherever it was, and the problem is we haven't reset our target, which means that we'll have our target set again. So essentially it will start ping-ponging again. Now one thing we can do is we can do this reset enemy thing in our other trees, right? We can say, a higher priority tree, just forget any enemies you had, which is kind of a little bit horrible, really. The other thing we probably want to do is we maybe want to look at, there is an event abort. I'm not actually sure whether this event gets called though. When the specific node goes out of the priority, so essentially when another tree takes over, it says in these nodes observer aborts. So I'm guessing that when the observer aborts says abort all of low priority, I'm guessing that it will receive an abort event, in which case we can basically just do exactly what we did there. Because actually that's fine. So if somebody takes over priority, or even if they don't, and we want to, instead of finish success, we want to finish abort. So basically, this node's going away, and we always need it to run when it exits to reset the value. So let's just handle the abort sequence as well. And you'll probably notice that we probably want to do the same kind of thing maybe on that as well. So let's just do that now. If you would actually come on the right monitor. Event received abort. And then just copy those nodes. Get rid of that one because we're not finishing execute. Finish abort. Yeah, hopefully that makes sense. So basically, in the failure case, when another tree takes over, we still want this logic to run. We still essentially want the resets to happen. So essentially, if it's going to normal progress, it'll go through this sequence and then reset. If something else runs that's higher priority than this, then it'll reset anyway, so that it won't necessarily run the next time round. And obviously you can choose whether you do that or not. You could maybe have a task that has automatic reset, or a choice of whether it resets or not. So we should have we've basically got the makings of most of what we need here, right? So what we can do is we can probably start working on adding something in the when it has the enemy selection. Actually, let's just check and make sure that that reset thing is actually happening, because I'm kind of worried about that now. So it sees us. It's going to come along. I don't think it's being reset. Let's just check the blackboard. Where's the... Okay, so that abort isn't being run. So there's definitely something we need to look at in terms of resetting these nodes. It's possible we could just live with essentially having a copy of this node under this graph at the start for now, but that's not my preferred way of dealing with it. But I think we'll stop that video for here for now, and then the next one we'll start adding something useful into when you see an enemy. An enemy? No, not a sea mollusk or something. No, we'll add some behavior in when we see an enemy. We'll probably have to look at classifying enemies a bit more, so that we don't just attack everything we see. What else can we do? See, the idea is that the hear noise thing should possibly be taken over by this. So essentially, this one will run, and then we'll see something, and we'll do something with it. Maybe we'll attack it or whatever. We might want to make this a little bit more complicated, because obviously right now it just moves to the position where it heard the sound and then does nothing, and then essentially goes back again. So what we probably want to do is we probably want to say, when we've reached that position that we were investigating, find some random location near it and walk around there for a short while, maybe do a pattern of behavior there, and then go back. So we can obviously flesh these two main areas out quite a lot more, but we'll save that for the next video. So this one we've covered simple reacting to senses, which I think is fairly useful so far, and we'll keep going in the next one.